Good afternoon, students. Can you able to hear me properly, Bhargavi? Good afternoon to everyone, guys. Good afternoon, students. Good afternoon, Karan. Good afternoon, Bhargavi. Today, Vishal sir will be not taking your class. I'll be taking your class because he is not feeling well. Okay. So, first of all, my name is Ankit. I hope you guys know me. I have done my BTech in telecommunication from SIT Tumkur, and I am teaching physics from past 3 years, almost 2 years. So I welcome each one of you to my class. Just ask your friends to join the class, guys. In today's class, we'll be learning actually about Doppler's effect. So if your friends have not joined the class yet, let them know that join the class. Okay. So those students who are having difficulty in understanding this topic, that is Doppler effects, today it's gonna get clear. Right. So I'm just gonna give you some tips and tricks and even some good techniques so that you can easily able to solve the problems of Doppler effects. This why it is important. I'm gonna let you know in within 2 3 minutes. 2 minutes. So I'm gonna start the class in next 2 minutes, guys. Just ask your friends to join the class. Let me check. Utilize students. Welcome, welcome, guys. So, guys, I'm just gonna launch the poll. Let me know whether I'm audible clearly or not. Let me know. I'm just doing technical check. Is my voice is clearly audible and is the screen is visible to everyone, guys? Let me know in the chat or just try to answer it. Am I audible clearly, guys? The one who cannot able to hear me, there might be some problem from your side because most of the students are saying that I'm clearly audible. So check it once. Check it once. Okay, students. So how are you all? Are you guys safe in your home? Is everything fine? Try to be safe, guys. This pandemic, everyone know that everyone is facing very severe issues, and uh, it is very sad news that past 3 days ago, our one of senior manager, I was very close to him, and lots of people, even students, were close to him. Deepak sir, he was no more. Uh, Due to severe COVID cases. So we will try to keep almost uh, 1 minute silence from your end that I am expecting. So if you want to close your eyes, you can. Else just let's be silent for 1 minute and let's keep our mind. Let's give his soul rest in peace. Okay, guys. So yeah, no, okay, fine. So have you told every one of your friends to join the class? Fine. Fine. Okay, fine. Okay, fine. So I think so. My voice is clearly audible. So guys, please be safe. From my end, I will be telling you. Try to make your loved one also safe. Okay, how much safe, and do your studies. Yeah, yeah, Sagar. That was really a bad news. I was very close to him, so lots of things were happening. So let us start our today's class. Let's uh, not go too much ahead. Okay, uh, fine. Mm. Okay, guys. So welcome to today's physics class. Those who don't know me, my name is Ankit, and I'm gonna teach you today for physics because Vishal sir is not feeling well today. Okay, so there is I contacted him. There is no problem on his side, so don't worry. Just let's learn peacefully the subject, right? So I think so. Vishal sir was teaching you the waves chapter, right? He was doing revision of waves chapter. Is it that, guys? Waves and oscillations. So you guys were doing basically the revisions of waves and oscillations, right? This is an important chapter with respect to physics, with respect to JEE as well as NEET when we go deeply in this chapter. So guys, my way of teaching, I don't know you know me or not. If you have any doubt or understanding anything, you can directly ping me in the chat. Okay. Good afternoon, Vijay. Yeah. So basically, utilized students also you can ping me in the chat and normal Zoom students also. So you can directly ping me in the chat. I'm gonna get you to the answer soon. Okay. Fine. So why this chapter is important? Because from this chapter there are few concepts, right? So like superposition principle and few other application of waves and oscillations are gonna come in this chapter, right? So one of the important topic that is that today Vishal sir was gonna teach you or make you understand was Doppler's effect. So I basically got to know that you might have little bit idea about Doppler's effect. If you have no idea about Doppler's effect, I'm going to teach you today the main topic of Doppler's effect. This is a very important topic. So let's move ahead actually. Then I'm going to make you understand each and everything, right? So first of all, it comes under waves, right? So we're going to understand about Doppler's effect, right? So this Doppler's effect, we will understand what is Doppler effect. Okay, why Doppler's effect, why we should learn this, that is an important thing. Okay, and how Doppler's effect. Okay, so for concept wise these two things are important. Why, what and why? For concept wise these two things are important because if you are preparing for JEE advanced or even JEE even, because they're gonna directly may ask the questions with respect to the how, including the concept, right? How Doppler's effect is gonna, we're gonna solve question directly formula. Fine, guys. But conceptual understanding of Doppler's effect is very important. So Doppler's effect is something not like that ki last 1 minute you see the formula and you think that you can solve each and every problem. No, you're gonna have to understand what is the concept, and then you have to also remember the way of formula. It is very easy actually, not very tough. Don't worry. And then you can easily solve it. Okay. So shall we proceed, guys? Is everything's fine? Have you understood little bit about like what we're gonna learn today? Shall we start? Can we have yes from everyone's side, guys? So are you ready with pen and paper? Just a minute. What happened? Okay. Okay, fine, fine. Just a minute, guys. It went bad. Okay, good to hear that. Good to hear that. Fine. So basically today's our main concern of topic will be nothing but what is Doppler effect. That is we're gonna learn in starting. What do you mean by Doppler effect? There are types of Doppler effect. Okay, so there are types. So most of the students get confused over here only. They understand what is Doppler effect, but they are really confused in the types, guys. Types is an important factor. Okay, if you are sincerely understanding that A for apple and B for ball and C for cat, right? So you basically know the meaning that A, B, C are three different terms. So if I'm writing B, there should be no confusion that what is A, right? So types is very important to understand before learning or going deep. Okay, and then we're gonna solve one or two questions, and next class we also gonna make you solve questions. Don't worry. Okay, so I'm also gonna make you solve questions based on it. Uh, Sir, which topic you were teaching in last class? Dhanush, in last class, we were doing the revision of the Sunday test. I hope you guys are remembering. So I haven't not took your last class, but I have seen Vishal sir was teaching you in last class, which was the revision of Sunday test. If you guys could remember. Is it fine, Dhanush? Is it clear? So today's class, we're gonna learn about Doppler's effect, and that is our major concern. Okay, this is just your revision, guys. Fine. So what do you understand by Doppler's effect? Okay, so let us first try to hear the is that superposition? Yeah, superposition of wave have completed, right, Dhanush? Superposition of wave is completed. No, 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 no. This is not superposition of wave. Sir, need paper not solved. Is it Radhika? Okay, no problem, Radhika. I was not knowing about it. Don't worry. Need paper will be solved by Vishal. Okay. Don't worry, Radhika. It will be solved by Vishal, sir. Fine. Everything is fine. It is not superposition of wave. It is a different effect. So I'm just going to make you understand. Try to understand it. Okay, guys? Fine. So let us first try to hear this voice. So can you able to hear? Can you able to hear it? So what do you think? What is happening over here? Yeah. Okay. Fine. Yeah. What is this? Okay. So what exactly is happening over here? You can't able to hear it. We could not hear, sir. I don't know. I have included a sound, but I don't. I can hear it. Okay. Okay. Fine. Fine. No problem. No problem. Don't worry. Don't worry. Okay. So let me. How can I make you hear this? This should be audible actually. Okay, guys. No problem. No problem. Okay. So let me put one scenario in front of you before going deeper. Disturbance created. Instead of saying disturbance created, let me put a scenario. Okay. So you are. This is you guys. Let us think this is you standing over here. Okay. Send in WhatsApp. Okay, Dhanush, I'll send after the class. Okay. This is you standing over here, and one train is coming from here. Okay, so this is by railway line, and you're standing on platform number 1, and one train is coming actually from here, right? And it is whistling, right? What it is doing? It is whistling. Okay, so when it is making its horn on, right? So what will happen? When you are standing over here, when train was coming, have you heard such type of voice? Can you imagine such type of voice? Because what exactly is going to happen? It is like pan, right? Or pan, right? So first what will happen? You will hear a sound from train, right? What will happen? You will hear a sound from train, and then the sound will come nearer to, and when train will pass out, again you will think that okay, sound is going far away from me. Have anything happened? Any one of you guys anytime like that? Or instead of taking train, you can take any bus example, any truck example, or any vehicle example that is making horn, and you are standing over here and you feel it. Okay, some voice is coming and suddenly it is going decreasing. Is it right? Is it right, utilized students? Vijay, is it right? Correct, na? So what exactly is happening is, yeah, same as relative motion. Yeah, correct. So what exactly is happening when you are standing over here? There was some wavelength that was produced by this horn, right? And when the car was far from you, you were hearing very less sound. When the car came near to you, oh, you were hearing, oh my God, lots of voice, right? So we also feel somewhat we used to close our ears. When train used to pass from nearby, we used to close our ears because train used to whistle a very loud noise, right? And when it goes far, we can hear the noise, right? Is it right? I hope you can assume the scenario. So this voice, what I was trying to hear you, which you can't hear, was the voice of light. It was the voice of car horn which was passing nearby. Got it? So the effect that is producing on you, basically, this is you guys. The effect that is produced on your ears, the effect that is produced on your ears is nothing but Doppler's effect. Okay, so let me put it in a technical scenario. This is practical scenario, guys. I hope you guys can visualize the practical scenario that what exactly is happening. That voice is coming, first of all, when it was far, it was coming low. When it is came near, the voice was coming very high. Again, it went far, the voice came very low. Again, it went far, the voice came very high. Again, it went far, the voice came very low. So what exactly is happening? That the voice came very high, the voice came very low, right? So this was practical. Okay, fine. So with respect to physical scenario, Doppler's effect is nothing but apparent change. So apparent change is nothing, just treat it as change. Let us not go too much deeply upon word apparent. Doppler's effect is change in frequency of wave motion in relative motion between the source and the observer. Okay, so before understanding this word what we have written over here, let us try to understand. First of all, there are two things that we are major concerned. Okay, first thing is source, and second thing is observer. Second thing is observer. So there are two things. Okay, so if I'm saying my source is train, then you are the observer. Then you are the observer. Correct? Is this correct, guys? So what could be properties of source? Source can produce sound. Source can produce sound. Can observer can also produce sound? Tell me, can observer can also produce sound? First. Tell me in the chat, guys. Can observer can also produce sound? That is a very normal question that I have asked to you. Think about it. What do you say? What do you think? What do you think? Good to hear from Mari. And okay, few students are giving me no, sir. Few students are giving me yes, sir. This is very double meaning question, right? So basically, observer can also, if I am the observer, I am making sound so that you are hearing it. Is it clear? I'm an observer. I'm making sound. If I'm a source, I'm making sound. So you guys are observer, you can also make sound. It is not that observer cannot make sound. Observer can also make sound, but when we are speaking the word observer, that makes us very defined that okay, observer are the one who's gonna observe, or who's gonna hear the thing, right? Who's gonna hear the thing, and source are the one who's gonna make sound. Source are the one who are gonna make sound. And just want to make you differentiate that an observer could also be a source. An observer could also be a source. So never think that if it is an observer, he can't make sound. There are questions that are complex in which they are making observer is also a source. Got it? So there are two basic most important thing. One important thing is source. Second important thing is observer. Source are the one that is producing sound. Observer are the one that is that could generally we used to say that is gonna hear the sound. Fine. So it is gonna produce the sound. It is gonna hear the sound. I'm just gonna write it down so that you can also note it down. Okay. So how we can treat Doppler's effect actually? So what is when we're gonna understand that we have seen when observer are at rest. So treat observer as you guys. You are standing and you are at rest, and train is passing in front of you. Train is passing in front of you while producing sound, guys. This chapter that we are learning is wave with respect to sound, right? Can you change paint color? Yeah, I am always changing paint color. Mari, I'm changing to yellow, red, blue. Is this fine? Which color you will be more comfortable? Is yellow is more comfortable, Mari? Red color is not visible. Okay, red color you are facing difficulty. Okay, so red color I will always only do for making underlines and all those things. Okay, so I'll use yellow. Yellow is best, sir. Okay, fine. So observe, your source is train and your observer is you guys. If your source is train and your observer is you, train is gonna make sound. Train is gonna make sound. That so let us not go physically. Let us understand it. Train is gonna what? Train is gonna produce some frequency. Train is gonna produce some frequency. So now I'm gonna teach you the same thing with respect to the physics. Okay, these are all things where with respect to the practical world. Okay, how practically is everything is happening. Now let me teach you with respect to physics. So we have source, we have source, and secondary we have observer. So what are all the properties that source or observer could be? Could there will be velocity of source? Tell me. Can there could be velocity of source, guys? Source can be moving or not? Tell me. Yes or no? Yes, sir. Source could have velocity. Or if source is at rest, that means source velocity is 0. Similarly, observer could also have velocity. So I'm just going to represent the terms, right? How are we going to write? So observer is also going to have velocity. That is V of 0. That is V of naught is not the velocity of observer. V of S is the velocity of source. Similarly, could source the could have the frequency? Could source could have frequency? Yes, if source is producing any sound, if source is producing any sound, I will tell that source will be having frequency, source will be having time period, as well as source will be having, tell me, source will be having frequency and time period are major thing. If you wanna if you're gonna go over it, you can also write source will be also having the wavelength, right? Source will be also having the wavelength. Similarly, if observer is producing sound or observer is hearing, guys, source property is to produce. Source property is to produce sound. Please make this clear in your mind. The property of source is produce sound. The property of observer is to hear the sound. Right. So if I'm saying that observer is hearing, obviously it is gonna hear some frequency. So I will tell that the hearing frequency or observer what is it is hearing is f naught, or time period at what time period is saying a t, or whatever free wavelength is hearing is lambda. Is it clear? Is these things are clear? So Doppler's effect says whenever there is change in frequency, guys, whenever there is change in frequency. Okay, whenever there is change, that means there is change in frequency. Whenever there is change in frequency, so let us go much more deeper. Whenever there is change in frequency due to relative motion between the source and the observer. I hope now you have got an idea. So if my observer is also moving, force is also acting. Yeah, Nandini, force is also acting. But right now we are talking about waves. What is Nandini? So let us think with respect to waves. We can also think most of the things, many things could happen, but we are talking with respect to waves. So we are taking all the constraint with respect to waves. So if there is relative motion between source and the observer, if source and observer both are moving, or if someone is moving and the other is not moving, and if due to that, if there is some change in frequency, if they both are moving and due to that there is some change in frequency, that is called Doppler's effect. That change in frequency is called Doppler's effect. Have you got an idea about Doppler's effect? Can you imagine it now? What is exactly Doppler's effect, guys? Don't treat the definitions as just reading and mugging it up. Understand it, you will never have to mug it up. Is this clear, guys? Is anyone here who is not understanding? Please let me know. I'm again repeating it. See, source is producing sound, observer is hearing the sound. Okay. Now, what is happening? If there is change in frequency between the source and the observer due to the change in relative speed, they are changing. Suppose source is moving here, observer is moving here, source is standing here, observer is moving here, source is standing here, observer is moving here, right? Due to change in relative motion could be our normal motion. If we accelerate, our vehicle go ahead, right? So due to change in relative motion, if frequency changes, now we say it is a Doppler's effect. Got it? So that's why they have written Doppler's effect is nothing but it is apparent change in the frequency of the motion when there is relative motion between, that is relative motion, change in relative motion between the source, that is very important term, and the observer. Is the definition is clear to everyone, guys? Is the definition is clear to everyone? Sir, you have to take example of sound. So please explain for light as a source. So basically, when we try to understand with respect to light, it comes under ray optics. So in a ray optics, also Doppler's effect is there. So with respect to light, basically light have dual nature, right? Everyone knows light have dual nature. Ray optics, wave optics. Okay, so in wave optics, we will be having sound, right? So when we talk with respect to light, so what do you think? Do star blinks? What do you think? Do star blinks? Dhanush? Yeah, Dhanush. So let me know, what do you think? Do star blinks? So generally star does not blinks. It always glow actually. That white color, whatever you see from your naked eyes, right? It always glow. What is happening, since it is a million and billions of light years away, due to the sky also, the light that is traveling atmospheric area, the light that is traveling from there is gonna see by our eyes, right? So in light, if you try to visualize Doppler's effect in light, what is we gonna use of Doppler's effect in light is we gonna find the distance, how far it is by the intensity of light. Okay, so how much light that is coming from the star to our eyes or to a camera, right? We're gonna examine the intensity of that light, and we can determine the distance, that how much it is distance. So this is my earth. Sorry, I'm using red color, so let me use yellow color. Okay, so this is my earth, guys, and this is my star, right? So that blinks due to atmospheric reflection, but the distance, how can I measure the different distance? So basically what is exactly happening, at the star side, it is producing some frequency, right? So it is acting like a source. Got it? And from earth you are an observer, so you are an observer, so you can see, is there any change in frequency? Is there any change in frequency? Can you see the change in frequency, guys? Can you visualize this? That's why I took the example of star blinking, right? Because frequency is changing over there. Got it? That's why I took the example of star blinking. Pramod, you are wrong. You have wrong in that. Got it, Pramod? So when I say star blinks, generally when we go near to star, you will not find it is white color. You will find it is very deeply yellowish in color or very burning in color. Got it? So you can't say that okay, it is white in color. That is due to the Doppler's effect. Is it? So in wave, what is happening when car is moving, you hear that it suddenly sound waves come increases and sound wave decreases. But in light, it is not like that. In light, it is like that either the wavelength of the light changes or frequency of the light changes. Understood, na? How can I visualize light, Doppler's effect in light? So using Doppler's effect in light, you can visualize either change in wavelength, change in frequency. Suppose from here, I can see red color burning, and after 2 lakh kilometer, I can see, okay, it is white color burning. That is due to the Doppler's effect, because there is change in frequency. Of change in frequency, either due to the atmospheric pressure or atmospheric reflection, that obviously matters. Yeah, Radhika, light and sound, both are different. Light exhibit both property, wave property as well as particle property. Light is having a dual nature. Got it? So light is having wave property. I'll just write it down. So I will not go too much on right now light, because in light also we have Doppler's effect. Concept will be same. That is change in frequency. That is what I'm gonna teach you. So light is having wave property, that is sound property, sound property, and it is also have particle. It is also have particle nature. So light have wave nature as well as particle nature. Got it? Is this clear, Radhika? Frequency remains same in any medium, sir, only it's apparent. Yeah, correct. Only there is a apparent. That's why this apparent word have been used over here. Is this clear, guys? Any other doubt that you are feeling with respect to your mind, sir, why this is happening, why this is happening? Doppler's effect is nothing but change in the frequency due to the relative motion. Our earth is also moving, or the star is also moving in itself. Due to change in relative motion, there is some change in frequency, and that is apparent change in frequency. What is the meaning of apparent, guys? Now tell me, what is the meaning of apparent? Now that comes into picture, guys. That's why I told you. What is the meaning of apparent? Think about it. What could be apparent? Seen to be by such thunderstorm lightnings which which is not real. Good. With respect to me, apparent means that is not really happening, that only I am seeing. Got it? So if I am seeing that a coin is there inside the glass of water, I am seeing that, okay, it is coming. I can see that, okay, it is, when I try to measure the depth, I will see the apparent depth. I will not see the real depth. But it apparent is just that is seen by the observer. Got it? So it is an important term. Apparent is what? That is seen by, oh, I'll use yellow color. Seen by observer. Seen by observer. Good to see that you guys are, and good guys, good. One students have asked me that, sir, what appears, but good. So thundering and lightning is which first happened first? Uh, Thunder and lightning, that is a different thing, right? When thunder happens, lightning happens, due to that sound wave is also been produced, and light wave is also been produced. That's a different mechanism only. Okay, so shall we proceed, guys? Okay, let's proceed. I hope you guys have now understood that first of all, Doppler's effect will be produced in sound as well as light, and the meaning of Doppler effect is nothing but change in frequency due to the relative motion. Light travel faster than sound. That's why you can see the uh, stars. If light will not travel that but simultaneously, but light travels faster. Yeah. Both simultaneously, but light travel faster. Yeah. So when if you burn a cracker, right, and it will go and burst in. So what you will see, your eyes will see suddenly. Okay, the cracker have burst, but after might be 1 second or might be 1.5 second, you will hear the sound of that cracker. Boom. Right. So that is a real practical life example that you can visualize and realize from your heart. Okay, light is faster than sound. Got it? Numbers are numbers, fine, but how can we visualize it in real life? Okay, guys. So if Doppler's effect is clear to everyone, good. If Doppler's effect is understand to you, let's move ahead and understand it in a deeper way. Okay, fine. So basically, what is exactly was happening in Doppler's effect? There was one source, and there was one observer. Observer. By so how can be there will be change in frequency? How? Right? So we're gonna understand how. How could be there a change in frequency? Change in frequency could be happen due to different cases. Okay, change in frequency could be happen due to different cases. It is very important point to understand these cases, guys, before learning the. Yeah, Dhanush, that is correct, Dhanush. So think about it here right now, Dhanush. Okay, so change is happening due to sources, due to source and observer. Now, what are the three major cases? So there are total three major cases, guys. First case, okay. So generally we used to say actually when your source is at rest, what is happening? When your source at rest, when your source is at rest and observer is moving, I'll just write like that. This is my first point. This is my first case. This is the case when I can say that my frequency is changing. Is this clear, guys? Is this case is clear? मेरा source rest पे खड़ा है. I can give you example that train at rest, train standing, right? And you are running. Train is standing and you are running. You are running. Is it clear? This is my first case. My train is standing and you are running towards the train or away from the train. So there could be two conditions actually over here. But this is my first case. Is this clear, guys? Second case scenario will be nothing but any doubt from utilized students? No one is, guys. Utilized students, try to participate in the chat. Just you will be watching video, then good to see that you guys are having no doubts. Okay. Second thing will be opposite of it. My source is moving. What is happening? My source is moving. And my observer is at rest. My observer is at rest. Is it clear? My second case will be my source is moving. My source is moving and my observer. That means you are standing, right? Take the example and understand it in a better way. That means you are standing, right? But train is moving. Got it? Train is moving. Okay. You are standing. So let us talk about these two cases first only in deeper. Train is moving. You are standing. Got it? My third case will be, can anyone tell me what could my third case? Think about it. What could be my third case? Think about it. Think. Tell me fast in the guys. Good. That means you guys are utilized students, guys. Most of the students are watching, but no one is replying. That is bad. My second case will be, or my third case will be, when both are moving. When both are moving, either so both are moving. Now, guys, tell me. So I will go deeper with each of the case. Got it? I will go deeper with each of the case. So let me take the first case in a deeper way. Okay. Okay. So I'll take, fine. So if my source at both are good. If my source is at rest, and you are moving. Okay. So let us take my first case. If my source is at rest and you are moving. Sir, if both are at rest, that comes into that. So if both are at rest, I will also take that condition. That is also comes into picture. But that is not going to affect anything. Got it? So, Mari, have you ever? Let me take example initially. Actually, that is comes into picture. When sounds waves are stationary source, right? When both are at rest, right? So this is your FM radio. Okay. You are listening some song. And you are just sitting over here. So are you gonna listen the song or you're not gonna listen the song? Tell me. Are you gonna listen the song or not? We are normally sitting. Okay, so I can show you example. Yes, sir. We are gonna listen the song, right? So what is happening? This is how the source look like. Can you see? So in middle, basically what we are having, the song. So in middle I am having this song, right? And song is producing what? What song is producing? The chapter what you are reading. Sound is producing what? Sound is producing waves. What sound is producing actually over here is waves. So sound is producing waves, right? And it is gonna come to your ear. Fine, Radhika. There are lots of example. So that is the example of water waves, Radhika. So it is gonna produce waves, right? I'm not going deeper that how it is gonna produce waves. Song, obviously, radio FM is there. It is gonna produce waves. Okay, so if it is gonna produce waves, if you are not, if my radio is at rest, if my source is at rest, and if you are also sitting over and you are also at rest, is there any change in frequency? Tell me. Is there any change in frequency? Tell me, guys. Is there any change in frequency? Think about it. Think. Fast. 2 students have told me answer correct. Other students, Vijay, is there any change in frequency? No. So if someone think about it, sir, if I am far away, I hear very less voice. That is change in amplitude. That is not change in frequency. Got it? If I am standing, suppose if I am being far away, that is changing amplitude, not changing frequency. If your mom is sitting in kitchen and you are sitting in bedroom and FM is there in your outside, right? So your mom might hear that sound very clearly, but you might not able to hear it clearly. That could be reason due to the amplitude, right? Obviously song changes, there will be change in frequency. Each word will be having different frequency, right? But what I'm trying to say, that whatever frequency that it is producing in a whole lot amount, suppose in 10 seconds, these many frequency it is producing, then in 10 seconds, these many frequency you are also gonna hear, right? So if there is no change in frequency, that means the observer, let me write, frequency produced by the source and frequency produced by the observer. If there is no change, then there will be any Doppler's effect? Will there will be any Doppler's effect? There will be no Doppler's effect. Doppler's effect will be only produced when there will be change in frequency. Is this clear? Got it, right? Doppler's effect will be only produced when there will be change in frequency. Okay, guys. So that's why we don't take the case when both are at stationary. When I'm also standing and radio is also standing, then what to think about it? Like they both are standing, right? And I'm clearly hearing his voice and nothing is changing. Whatever frequency that the radio is producing, I can hear it clearly. Is it clear, right? Only if I go backward, I can say that, okay, my amplitude is changing. Got it? Now we will try to implement relative actually. What we'll try to implement will. So our normal formulas, guys, I'm just gonna write down the normal formulas. Yeah, wavelength formula is nothing but wavelength is represented by velocity of sound, of velocity of sound divided by frequency, right? Frequency. This is our general formula. This formula at least you should remember. Same repeats when both are moving. Yeah, correct. When both are moving, that is comes under beats, right? So this is the normal formula that you should know before basically normal. That is wavelength is nothing but velocity of sound by frequency. Fine, right? I hope everyone knows this formula. I don't have to teach it. Right. Frequency is also written as 1 by time period. Frequency is also written as 1 by time period. So these all formulas you should be knowing. There should be no confusion in remembering these formulas. So wavelength can also written as velocity multiplied by time period. Wavelength can also written as velocity multiplied by. So these three combinations will be vastly used in this concept anywhere. Got it? Fine. So let us try to understand case by case. What is velocity of sound? Generally, we used to say 330 meter per second or 334 meter per second. So they will provide you in the question. If they don't provide you, take 330 meter per second or 340 meter per second, Radhika. Got it? Okay, let's move ahead. Let's understand case by case. Okay, so let us understand the first case, guys. So we will try to understand first case. In our first case, what is happening? So what was our first case? So write it down in your notebook. My first case was my source is at rest and my observer is moving. My first case is that my source is at rest. That means train is standing and you are moving. Think about it. Just visualize in your mind for 2 minutes. My train is standing and I am running towards the train. Guys, just visualize this. My train is standing and I am running towards the train. What could be the conditions? What could be the conditions? There could be only two conditions. First condition, either you are running towards the train, that is you are running near to the train, or you are running away from the train. Is it clear? Is the two condition clear? Either you are running towards the hospital or you are running away from the hospital. Hospital is at rest, right? Train is, got it? If police vehicle is standing, either you are running towards the police vehicle or you are running away from the police vehicle. So there are two cases that is coming picture in everything. So those two cases, these are under cases, guys. First of all, there are three cases. That is why I want to make you understand. If you want to give me a nomenclature, I can give you a nomenclature also. Under this source at rest and observation, there are two conditions. That is, first condition is towards, and second condition is away. You need to understand it carefully. Towards means near to it. Towards means this you are moving towards the train. I hope you know the English, right? And away from, you are moving away from the train. Got it? Fine. So let us see the case. So this is you, guys. This is observer. This is you. Okay. So you are very happy and you are very good, right? Fine. So let's move ahead. So this is you. Fine. You are standing over here. You are not moving. Okay. Sorry. You are moving actually. When observer is moving towards the source, what is happening? Observer is moving towards it. What is happening? Think about it. You are trying to run towards the train. Okay. So this is my train. What is this? This is my train. So train is at rest. Is it clear? You are trying to running towards the train. So what is exactly is happening is, if this train is gonna make noise, if train is gonna make some horn, okay, train is at rest and train is gonna produce some horn. Is it clear? So what train is gonna produce? Is train is gonna produce some? Is train is gonna produce? Yeah. So is train is gonna produce some wave? Tell me. Is this train is gonna produce some wave? I don't know how this happened actually. This should be on the left hand side actually. Okay, fine. So what is exactly is happening? If train is producing some horn, so what is happening? Train is trying to produce some waves. Train is trying to produce some waves. These waves are gonna hear by you. These waves are heard by you, right? So what is velocity of uh, train is a velocity of train is how much? So velocity of source, train is source. How much is velocity of source? Tell me. My velocity of source, I'm gonna write it down. My velocity of source is 0 because train is not moving. Got it? My velocity of source is 0 because train is not moving. My velocity of sound produced by the train. My velocity of sound produced by the train is V, normal V. Right? We used to write normal V, that is speed of sound. That could be 330 meter per second. Fine, right? 330 meter per second. Normal speed of sound. It is going to produce sound that is normally in air. Sound produces 330 meter per second. Okay, now first case come under the case comes into picture is towards the source, guys. Towards, so you are moving towards the source. What you are doing? Train is at rest, you are running towards him. What is happening? Train is at rest, you are running towards the train. What will happen? Think about it. What could happen? Do you gonna hear the sound faster or do you gonna hear the sound slower? Tell me. If train is running towards the observer, is you are running towards, it is increasing, you will feel that okay, so voice is increasing, there is change in something, right? There is some change, something is changing, right? Faster, more sound, correct, right? So we are taking speed. So the observer is, or the, you are running with a speed of velocity v naught. Got it? You are running with a speed of velocity v naught. And if you're running with a velocity v naught, train is at rest, what we can write? Normal frequency produced by train will be how much? Velocity of sound divided by the whatever will be frequency, right? Divided by the lambda wavelength. This is the actual frequency produced by train. Normal frequency produced by train. We have to find how much is the frequency, heard by the observer. Observer will hear how much frequency, right? So how can we find it actually? Tell me the sound that is gonna come, or the sound that is gonna come inside the ear, right? So my velocity of observer is in this direction. I'm using blue color. Watch it out. My velocity of observer is in this direction, and velocity of sound is in this direction. Got it? So what is the relative velocity? Tell me, what is my relative velocity? Shall I write? What will be the net velocity that will be produced? Good, Pramod. So my relative velocity will be nothing but, see, this sound velocity of sound is already in positive direction, but my velocity of observer is in negative direction. So what can I write? Relative velocity. So I can write relative velocity to the observer. That is what we can write, relative velocity to the observer. So let me write VR will be nothing but velocity of sound plus, so if you wanna write a relative velocity should be negative, right? So we'll write minus times of v naught, right? So which will be nothing but velocity of sound plus velocity of observer. Is this clear, guys? So important thing to remember is that when you are trying to running towards the stationary object, if you are trying to running towards a stationary object, your velocity will get add up. The velocity will get add up. You will hear it much more faster. You are trying to get much more faster voice, right? If you have got the velocity, can I put this in the formula? I know. So I have to find my new frequency. How much frequency will be produced by the, so I'll just try to write it down actually over here. So how much I'll be getting? My velocity of sound will be nothing but velocity of sound by to the source that he will be hearing to his minus y. Minus y. What is relative? What is relative A of A and B? Tell me, Radhika, fast. What is relative of A and B? Fast, tell me, Radhika. Fast. Guys, this is very conceptual thing. What is relative of A and B? Radhika, third chapter, second dimension. VA minus VB, correct? VA minus VB or A minus B. Got it? So I hope now you have understood. So we are writing V minus of minus V naught. Is this clear right now, Radhika? Is this clear? This is relative term we are writing. Vm minus Vb. Got it? If someone is asking, sir, why this is negative? Guys, if we are moving towards the left hand side, we used to write as negative. If you are moving towards the right hand side, we used to write as positive. If you are moving towards the top hand side, we used to write as positive. If you are moving towards the down side, we used to write as negative. This should be a very clear understanding to you. Okay? Fine. So my relative velocity is nothing but V plus V naught. Got it? Let me put it in this formula. If I try to put it in this formula, what I'll get? My apparent frequency. So how can I? So my normal frequency is nothing but F is equal to velocity of sound divided by wavelength. This is my actual frequency that is coming outside from the 10. Right now my velocity is changing with respect to the source. My velocity is changing. What is happening? My velocity is changing. So I will write it down. My new frequency will be how much? My new frequency will be nothing but my change velocity. How much is my change velocity? You can see my change velocity is nothing but V plus V naught. So I will write V plus V naught divided by lambda. Got it? V plus V naught divided by lambda. Is this clear? So instead of writing it in this form, you can write it in this form. My change frequency will be nothing but I can write my change frequency will be nothing but V plus V naught divided by lambda, right? And what is the value for lambda? You can see frequency F is, so what we used to write this as, this we used to write frequency of source, guys. What we used to write? We used to write this is frequency of source and this is frequency of observer. F of O represent frequency of observer, F of S represent frequency of source. So you can write frequency of source is nothing but V divided by lambda. So lambda is nothing but V divided by frequency of source, right? Let me put this over here. So what you will get? You will get my new and the actual frequency will be nothing but, if you put the value for lambda, if you try to put the, if you try to put the value for lambda, what you will get? You will get the value, my frequency, that is F dash only. F dash is nothing but F of naught, that is frequency by observer, will be nothing but V plus V naught divided by lambda value is V by S. So V multiplied by F of S. This is a very important formula. This is a very important formula. Don't mug this formula. Don't mug up this formula. Okay, don't mug up this formula. I will teach you a very interesting method. Sir, how is it velocity is minus V naught? Pramod, what is relative of A and B? Pramod, you are asking me the same problem again and again, Pramod. What is relative of A and B? Please tell me. Pramod, what is relative of A and B? First, Pramod. What is relative of A and B, Pramod? Just now I asked you, Pramod. VA minus VB. This is my A, this is my B. So my A velocity is V, my B velocity is minus sign is already there. My B velocity is minus V naught. So how much I am getting? V plus V naught. Is it clear now, Pramod? Is it clear now? These are basic things, guys. You need to be very clear in this. If you are learning this first time in your life, that okay, I have learned this first time or understood this first time, then make a habit of learning new things for first time. You still have times. There is time for JW. Sorry, very less time actually, but still you have time few times, right? Before this 1 June is the time they're gonna decide what is gonna happen, when the Gemins is gonna happen. Okay, fine. Okay, let's move ahead then. So my normal frequency, the frequency. So this is the frequency through which he will hear. This is the frequency through which observer will hear the sound is coming towards him. Is there increase in frequency or decrease in frequency? By seeing this formula, F of naught, I'll write it down yellow color. Is this increase in frequency or decrease in frequency? F of naught is equal to V plus V naught divided by V multiplied by F of S. It is increasing. It is increasing. Everyone is clear with this, right? It is increasing. Since it is increasing, what we will say, write down this thing. I will write it down. When observer is moving towards source, frequency increases. When observer is moving towards source, frequency increases. Is this clear? Is this clear, guys? When observer is, write it down, guys. You have to keep this in mind, and this is very general thing. Just visualize it. When observer is moving, when you are running towards train, you hear the, okay, obviously train, when train is moving towards train voice, you will hear much more voice, right? Practically you can understand. If a car is making some horn and you are running towards that car, you will feel, okay, the voice is increasing towards your ears. Got it? So if my observer is running towards a train or any other rest body, right, my frequency will increase. Is this clear? What will happen opposite of it? What will happen opposite? That is, opposite of it means towards. Not towards. The second case will be away. My second case will be away. Same thing. Everything will be same, guys. Watch it out carefully. Everything will be same. What is happening? My observer is moving. Same thing, guys. Last case also, observer was only moving. You were also moving. This is you, guys. Last case also, you were only moving, and now also you were also moving. But this time you are not moving towards the direction of train. But you are moving? You are moving away from the direction of train. Got it? You are moving away from the direction of train. Understanding? So what do you think? Frequency will increase or decrease? What do you think? Frequency will increase or decrease? It will decrease. Good. So my frequency. So what is this frequency? What is this apparent frequency means? What is this F naught? We are writing F of naught over here. That will be F of naught is equal to nothing but, we will write, that is speed of velocity minus velocity of observer divided by velocity multiplied by F of S, frequency of source. This is my general formula. See over here, negative is coming because it is decreasing. If you are running away from observer, you should write minus sign that represent it is decreasing. When you are running towards the observer, it is positive sign, which means it is increasing. Okay, what is this F of naught, guys? If this F of naught is the apparent frequency. Actually, there is nothing called F of naught. It is just you are listening that voice. But it is just you are hearing. This is apparent frequency. But it is just you are hearing from your ears. Actually, is the train frequency changing? Is the train frequency changing in real time? In real time, is the train frequency changing? It is not changing. Train is always producing frequency in that FFS only. Only you are hearing change in frequency, and that's why we are learning Doppler's effect, because there is change in frequency. Got it? Is this clear? Is case one is clear? In case one, there are two terms. First thing is towards. Second thing is away. It is very important to understand this. In case one, you are trying to running towards a rest body. You are trying to running towards a rest sound producing waves. Frequency will never change. What? Frequency will change, Radhika. Frequency will change when source is running towards you. Sorry, frequency will never change. Frequency is changing now. Who is saying frequency will never change? Are you talking about train frequency? Are you talking about train frequency, Radhika? If you're talking about train frequency, guys, is there any change in frequency of train and car? Tell me. Car is making different type of horn, right? And your train is making different type of horn, right? So if I'm saying that A, suppose let me use word A. Okay, so how you pronounce A? A. Everyone says sir, A. Different is people use different type of frequency of speaking the same word only. There will be very slight difference only, but you can see that the frequency is same. Got it? So that is what we are taking the example of car horn. So we are thinking right now that car is pressing or train is pressing his horn at same frequency. There he is not changing his frequency. Got it, Radhika? Understood now? So he is not changing his frequency. He is making the horn in the same manner only. Even though he can change, but obviously you know, I have not seen any car who's singing some song used as a horn. I have always heard pa pa poo poo pa poo like that. Have you heard like horn? right? Very few cars will be there. Obviously, there will be, but very few cars will that will be using such kind of horns, right? Generally, we use pa pa pa, right? Fine. So we don't change that pa 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 frequency. That pa 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 frequency is always same. But if you are running towards that pa 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 frequency, the frequency that will be heard by your ears will be changing due to the Doppler's effect, and that is what we will learn. So this formula is clear to everyone, guys. Don't mug up this formula. I'm gonna explain you a very easy technique in last that is gonna help you to remember this. You don't have to mug it up. But you have to understand what is happening when you are running towards the observer. Frequency is increasing. When you are running away from the observer, frequency is decreasing. These are two important concepts that it should be there in your mind. Is this understandable? Fine. Any doubt, guys, you can ask me understanding this. Else we can move to second case hour. Okay. So seems no doubt. Good. Sir, when trains approach, we hear amplitude increasing, then how we hear frequency increasing? Dhanush, this is a very impractical question you are asking, Dhanush. You are asking me, if train is approaching, we hear amplitude increasing, then how we hear frequency increasing? This is what I'm gonna teach you. Just second slide. Got it, Dhanush? Try to go opposite. Watch it out carefully. If you try to go opposite, now my source is moving. Watch it out carefully. This is my second case, guys. Sir, if both person move opposite side, don't think about that, Radhika. I'm gonna teach you. Don't think about that. Else you will be confused. Whatever I'm teaching you right now, watch it out. In last, I will be clearing every doubt. If you will be moving like that, if you will move like that, if you will move like that, what will happen? Got it? So think about what you know, and then I'm gonna teach you. Okay, source is moving towards observer. Now what is happening? You are standing, guys. You are standing, and what is happening? Train is coming towards you. That was your question, right? Now I am standing and train is coming towards me. So there is a deep physics actually inside it. Understand it. So if my train is coming towards me, what is gonna happen? Tell me. What is gonna happen? Are you gonna again? Is there will be any change in frequency? Yes or no? Tell me. Again, is there will be any change? Yes, there will be change in frequency. You will hear train is coming like that, right? You have not heard. You will not hear like that. It will increase. When train will come nearby to you, it will increase. That it increases, right? Frequency increases. Got it? Fine. So we will try to understand whether it increases or decreases. So what is happening actually over here? Okay, so I'm taking one case. Understand it properly. Okay, so this is my train, guys. You can see the downside one. Okay, I'm just gonna watch it out here. Watch it out. Everyone, keep your eyes here. So this is my train. Okay, so now my train is making noise. Previously also my train was making noise, but previously my train was at rest. Now my train is moving. Okay, so my train is having some velocity. What I will do, I will say my train is having some velocity. Okay. Yeah. So let me take the velocity of train as V of S. What will take? Velocity of train as V of S. V of S. This is my velocity. What is velocity of observer over here? Tell me. My velocity of observer will be 0 because observer is at rest. Okay. Now, guys, again watch it out over here. The diagram that is over here is this is my train. Okay. Train is producing some waves, right? Train is producing some waves. So these waves will be going over here. These I am trying to draw the waves. So you can see the crest, you can see the trough, right? So when this is my one wave, right? This is my one wave which is completed over here. Let me write down this as W1 and this as W2. Got it? So I'm just writing this point as W1. I'm writing this point as W2, right? What will happen after some time? So when train was standing over here, he have produced some waves. When train was standing over here, he have produced some waves. Is it right? Now, after some time, what will happen? Is the train is moving? Think about it. Is the train is moving? Yes, the train is moving. After some time, the train will come little bit forward. What will happen? The train will come little bit forward. What will happen? The train will come little bit forward. You can say. So previously my train was over here, right? Now my train have came little bit forward. I don't know how much forward, but now my train is little bit forward. So if my train have came little bit forward, will he is gonna produce same wave or he is gonna produce different wave? So he again is gonna produce the same wave because it is the ability of the horn to producing same wave. Horn generally produce same waves, right? So train is again gonna produce the same waves, right? So you can see actually over here, what was the width of the, what was the time period or what was the wavelength of the train? So what we can, so guys, I have to switch off my video. Actually, there is some problem. Okay, clear, sir. Good to hear, sir. Both are going good. Okay, now I can see your. Uh, good to hear, guys. Okay, just a minute. Yeah. Okay, fine. So when we speak of wavelength, so what is happening when source is moving towards observer? Now my wavelength is changing. My wavelength is changing. It is very important property. My source is moving towards observer. My wavelength is changing. How my wavelength is changing? I'm just going to write it down actually first over here. My wavelength, my wavelength is changing. How it is gonna move or how the wavelength is changing, let us see. Okay, so initially my train was here in my position 1. Now my train have came to position 2 because of the speed of the train. This is happening due to the speed of train, right? Now what is happening? How much distance the train have traveled? Let me calculate. The train have traveled some distance, that is the train, instead of saying distance, let me say the train have, how much the wavelength the train is changing. You can see from here actually, just a minute. Yeah, you can see from here actually. So in the wavelength, so wavelength is represented by what? So you know, a wavelength formula is nothing but velocity divided by, so I'll write it on in yellow color. Wavelength formula is nothing but velocity divided by frequency. If I am writing with respect to time period, I will write velocity multiplied by time period. So whatever will be the time period with respect to time period multiplied by velocity of train, that is velocity of source, will give me the distance. So train have moved this much distance. Is this clear? If I know the speed of train and if I know the time, how much train have took that time, I can say that it have moved that much distance, right? Like that, if I know the time period of the wave and if I know the velocity of the train, I can easily say that, okay, train have moved this much, moved ahead, right? And what will be the, what will be the velocity of the wavelength of the wave? So my wavelength of the wave that is produced by train, that is lambda, is nothing but velocity. So I'll write V of S over here. Speed of sound multiplied by the time period. That is this frequency. Is it clear? This is what wavelength says, right? This is what the definition of wavelength is there, right? Is it right? Right? So you know wavelength definition. Is it clear? Is this clear to everyone, guys? Wavelength. What is the definition for wavelength? Distance between two waves. How much is the distance between two waves? So distance between my first wave is nothing but velocity of sound multiplied by the time period of the wave. And what is, how much the train have moved? Train have a velocity of train multiplied by the, that is velocity produced by the source multiplied by the time period, right? So how much is the actual wavelength that is going towards the source? How much is the actual wavelength that is going to? So what will happen after some time? What will happen? This has become W1, right? This have become W1 over here. W2 have moved. So this process will go continue. Now my after some time my train will come over here. It will produce some wave over here. So this will become my W1. After some time again my train will come ahead, right? So train is moving and it is also producing some sound. What it? So the sound that it is producing, I am representing it with respect to red color wave. And train is moving, I am representing it with respect to the blue circle. So with respect to time, now my train is also moving. Got it? So if my train, so how much is the amplitude or how much is the wavelength that is train is producing, or apparent, you can say apparent wavelength. So apparent wavelength that train is frequency is nothing but the total wavelength. So total wavelength is nothing but, see the total wavelength. So you can see from here, this is my total wavelength, guys, right? And train have moved this much wavelength. So my apparent will be how much? My apparent will be this much left out part. So how much will be my apparent? So we will write, so let me write apparent by lambda. So I will write my apparent will be lambda of E will be nothing but the total wavelength. Total wavelength is nothing but that is velocity of sound multiplied by time period minus apparent will be nothing but minus velocity of source multiplied by the time period. This is my apparent wavelength. Is this understandable, guys? Is this understandable? This is how the wavelength is changing. When I'm speaking that my source is moving towards the observer, this is how the wavelength is changing. Right? My total velocity, my total wavelength that is produced by a normal wave, and once it have moved ahead, my total wavelength produced by the wave produced by the train. Okay, what will be the velocity of sound over here? Tell me, what will be the velocity of sound at in observer end? Can you tell me? So train is moving in right hand side, that is velocity of train is velocity of source, and velocity of sound is in this direction. This is my velocity of sound. What will be velocity of sound on the observer end? Tell me, guys. Relative term. What will be my velocity of sound over here? First, Sanjeevni, Rakesh, Rajalakshmi. What will be my velocity of sound over here on the right hand side? Guys, no one is replying anything. Is this like you are not understanding? If you are facing difficulty, I'm going to explain it once more. We have time. Oh no, we don't have time. Okay, we have time so that I can understand you the concept. Okay. Okay. So let me make you understand this again, because I can see most of the students are leaving the class without saying that I'm not understanding also. That is their nature. Okay, so I'm just gonna make you understand again, because I'm only feeling underconfident from my side that you guys are not understanding. If you're not gonna tell, that how can I make it? That is wrong, Kavita. That is wrong actually. If my velocity of sound, is v, and my velocity of source is v of s, what will be the velocity of sound in the observer end? My velocity of sound in the observer end will be v only. It is not v plus vs. Got it? This is the wave nature. This is not particle nature. Have you understood right now? This is the wave nature. This is not particle nature. So it is like that train is moving and it is producing sound. So whatever sound that is producing, it is not key sound. Whatever sound it is producing, it is not key. Its speed will be adding with the speed of sound. Understood? Have you understood this? So if my train is moving, watch it out carefully. You can see in the diagram actually. If my train is moving and it is producing some sound, it is producing some sound. It is not like that if train is moving also and it is producing some sound also, sound velocity plus train velocity will add up and then I can hear it. No, it is not like that. It is a wave property. It is not particle property that both the velocity will get added up. Right? It is producing sound that is coming outside. Simple, normal thing. And sound is having a velocity of 330 meters per second. Right? So whatever the velocity that observer will be hearing will be v only. Right? He will hear with the velocity of sound only. It is not he will hear with the velocity of something else. Got it? Fine. So this was the first concept that you should understand basically. So my observer velocity will be v only. It is not that my velocity will change. That is velocity of sound will be coming on as v only. Okay. Now I'm gonna make you understand this again. Initially my train was at position 1. He was standing. He was running. Right. After some time, what will happen? My train have moved a little bit ahead. Why? Because it is having some velocity. Since my train have came to this place, so I will try to find how much wavelength have been changed. So I can actually easily find the wavelength, right? So how much wavelength that train have changed? The wavelength that change nothing but, you know, wavelength formula is nothing but, wavelength is nothing but velocity of source multiplied by time period. So velocity of source multiplied by time period. We represent by V only. We represent by V only, Radhika. We represent by V only. That is velocity of sound. Velocity of sound is represented by V only. Got it? Fine. So this is the wavelength change. How much is the total wavelength? My total wavelength was nothing but the total velocity, that is velocity of sound multiplied by the time period. Right? That was my total wavelength. So how much is the wavelength that has been hearing to the observer? So the wavelength that has been hearing to the observer will be left out wavelength. Only this wavelength will be produced every time. Right? Because every time what will happen, after some time observer will come here, after some time observer will come here, after some observer will come, so it is going to move ahead. So every time it is going to produce this much wavelength. So how much is this wavelength? This wavelength is nothing but, it will be nothing but lambda times of, suppose if I'm writing E, you can write lambda is nothing but total wavelength, that is velocity multiplied by time period, minus the wavelength that is produced, that is gained by the train, right? Train, which is the velocity of sound, velocity of source multiplied by time period. This is my wavelength. Got it? So you know frequency of an observer is nothing but f of naught is nothing but velocity of sound divided by wavelength. Right? This is the wavelength through which observer will be hearing. Sometimes they ask you directly in this question, find the wavelength through which observer will be hearing. So I hope now you guys have got a clear understanding that what is the wavelength observer will be hearing. Now we can put it down actually. So what is the wavelength that observer will be hearing? If I try to put down in the formula, we'll get f naught will be nothing but velocity of sound divided by the wavelength. So we have find it out the wavelength. So wavelength is lambda of e. So we'll put it down. So we'll got v minus vs 1 by time period multiplied by time period. Time period is common. So 1 by time period is how much? 1 by time period is nothing but frequency, which is written by f of s. So this is our formula. So the frequency that observer will be hearing will be nothing but velocity of sound divided by velocity of sound minus velocity of source multiplied by frequency of source. Got it? Whether it is decreasing or increasing, tell me. Whether this value is decreasing or increasing. Tell me guys. सर एक्सप्लेन इन हिंदी. देखो हो क्या रहा है कि सोर्स जो है ऑब्जर्वर के पास जा रहा है. ठीक है, अभी सोर्स के पास कुछ वेलोसिटी है, मतलब ठीक है, तो सोर्स और सोर्स जो है जो वेव जनरेट कर रहा है वो स्पीड ऑफ साउंड के रिस्पेक्ट में वेव जनरेट कर रहा है. ठीक है, तो सोर्स तो आगे बढ़ ही रहा है, लेकिन वो जो साउंड है वो स्पीड के रिस्पेक्ट में जो वेव्स प्रोड्यूस कर रहा है वो तो स्पीड साउंड ऑफ स्पीड के रिस्पेक्ट में ही प्रोड्यूस करेगा, भले ही सोर्स आगे जाए पीछे जाए. गॉट इट? सो यहाँ पर क्या हो रहा है कि यहाँ पर जो फ्रीक्वेंसी जो वेवलेंथ प्रोड्यूस हो रहा है बाय नॉर्मल वेव इज इन स्टार्टिंग बाय ट्रेन वाज नथिंग बट द टोटल वेवलेंथ एक हम लोग इतना मानते हैं, इतना टोटल वेवलेंथ, ये डिस्टेंस टोटल वेवलेंथ होता है, ये हमें पता है. राइट? टोटल वेवलेंथ कितना है? वेलोसिटी ऑफ साउंड मल्टीप्लाइड बाय द टोटल टाइम पीरियड. गॉट इट? एंड थोड़ी देर के बाद इतने ही टाइम पीरियड में, in this time period only, what is happening? The train is moving this much distance ahead. The train have moved this much wavelength ahead. ट्रेन का इतना वेवलेंथ आगे चला जा चुका, तो ट्रेन के पास कितना वेवलेंथ बचा? ट्रेन इंस्टेड ऑफ सेइंग ट्रेन, साउंड के पास कितना वेवलेंथ बचा? साउंड के पास बस इतना ही वेवलेंथ बचा, और यही वेवलेंथ है टोटल वेवलेंथ माइनस साउंड के पास जितना वेवलेंथ बचा. राइट? इज दिस अंडरस्टैंडिंग प्रियदर्शनी? गॉट इट ना? So this is decreasing or increasing, guys? So most of your students are saying it is increasing. Think about it. V divided by V minus Vs. So you can 5 divided by 5 minus 2. Is it decreasing or increasing? 5 divided by 5 minus 2 is 3. Don't never get confused, guys. Don't feel confused. Don't get confused. I just make one statement and you get confused. Sir, decreasing, sir. Don't get confused. Stick to your points. Say why you are sticking to your points. If you're sticking something, there should be reason behind that. Is this understandable, guys? Fine. So you can see for increasing, it is increasing. What is, so those students have just suddenly changed their answer from increasing to decreasing. That is wrong. It is increasing. You can see the wavelength, the frequency is increasing. If my frequency is increasing, so I'll write it down, increasing. So if the train is moving, or if the source is moving towards the observer, it will increase. And what will happen to decrease? What will happen to decrease? So second case, if my source is moving away from the observer, if my source is going away from the observer, it will, wavelength is increasing, frequency is decreasing. Wavelength is decreasing, frequency is increasing. Got it? Sahana. So I asked frequency very clearly. I told, but how the frequency is it increasing or decreasing? So if I am writing with respect to the away, so that was the condition for towards. If I'm writing with respect to away, my frequency will be nothing but V divided by V plus Vs multiplied by F of S. So is it increasing or decreasing? It is decreasing. It is decreasing, right? Fine. So I'm just gonna give you an overview so that you can remember it for a longer period. Watch it out carefully. And I'm gonna give you one trick. Okay, guys. So yeah. Fine. So we have two cases. So this is my source. This is my source. I'm just gonna write it down over here in two conditions. Okay. I'm just gonna make one line over here like this. Okay. So case 1, case 2. If so, case 1 also having two cases. One is towards, one is away. Remember like this, I'm damn sure you don't have to mug it up. One is towards, one is away. Even I also don't have to mug it up. I don't have to mug up the formula. I just remember it. But it, so towards means what? Towards away, towards away. But it in towards and away, towards and away. So case 1 is when source is at rest. When source is at rest, observer is moving. So I'll write like this. Okay, I'll write S and O. S O. I'll write source at rest and observer is moving. Right? If source at rest and observer is moving, if observer is moving towards source. Okay. So tell me what was happening. So I'll try to write it down. It is source is at rest and observer is moving towards. So whether the frequency was increasing or frequency was decreasing. Frequency was increasing or frequency was decreasing. Tell me first. If source was at rest and observer, frequency was increasing. Remember it like this. Frequency was increasing. Increasing means positive sign. Increasing means positive sign. Got it? Increasing means positive sign. Similarly, if it was away, then I will say frequency was decreasing. Is it clear? I hope this is clear. Decreasing. Then I will say it is negative sign. But it was ekdam opposite. It was ekdam opposite in this. In the case when source was at moving, when source was moving and my observer was at rest. Right? So in this case, so I'll just write it down. My source, so I'll instead of writing like this, I'll write it down. This is my source. My source is going towards the observer. Right? Frequency was increasing or decreasing? Tell me first. Frequency was increasing. Frequency was increasing. But sign is opposite. Frequency was increasing, but sign was opposite. Sign was negative. This is where the lots of students get confused. In order to remember actually small thing. I hope you guys could remember the small things with respect to the so I'll just write it down. So this is my source. Over here observer is moving ahead. Over here what is happening? My source is, why I'm writing 8F. My source is going in this direction and my observer is at rest. My observer is at rest. Right? So my frequency was decreasing. My frequency was decreasing, but my sign was positive. Why this is very important? Why this is very important? Now let me teach you something important, that is with respect to the formula. Okay. So my general formula says, my general formula generally used to look like. Watch it out carefully. I'm damn sure you can easily solve all the problems using this formula, and you can easily solve it. Okay. So my third case, my case 3, guys. These were my third case. Now my third case comes into picture. That is when both are moving. When both are moving. Under this case, we have we have 4 different criteria. So under case 1, we have 2 criteria. So I'll write it down. Under case 1, I have criteria 1, criteria 2. Under case 2, I have criteria 1, criteria 2. Under case 3, when both are moving, I will be having 4 different cases. How to remember this, sir? Then how can I remember all these 8 formulas? You don't have to remember this all 8 formulas. You just have to remember one formula. That one formula that you have to keep in mind is that f of naught is equal to, write it down, f of naught is equal to v, and then write v naught divided by v, and write vs multiplied by f of s. Just remember this formula, and with respect to this concept, you can easily find it out. Okay, just remember this formula. This is a very general formula. I'm just trying to write it down, and then I'll move ahead. Got it? Now let me show you how we can remember it actually. So let me take the first case. Now both are moving, guys. Now both are moving. So if my source is moving in this direction, okay, and my observer is also moving in this direction. So I'll just write it down in this way so that it could be more good. My observer is moving in this direction. Okay, and my source is moving in this direction. Tell me what formula will be. F of naught will be what? I'll just write down the formula. Which is nothing but v naught divided by v vs multiplied by f of s. Both are moving towards each other, guys. Now remember with respect to whatever you have learned. If my observer is moving towards the source, shall I write positive or negative? If my observer is running towards the source, shall I write positive or negative? Watch it out. So in first case, my observer is moving. In first case, my observer is moving. In second case, my source is moving. If my observer is moving towards the source, what is happening? I should write positive. Is it clear? So I will write positive. Got it? So you can see my observer is moving towards the source. What source is doing? His source is moving towards observer. From the left hand side, can you say my source is moving towards the observer, guys? Yes, I can say my source is moving towards the observer. So what will happen if my source is moving towards the observer? See, my source is moving towards the observer. My source is moving towards, shall I write positive or negative? My source is moving towards the observer. Shall I write positive or negative? I should write negative. I can see most of the students are giving me correct answer. Good, guys. Good. That means you guys are understanding. I will write negative. Right? It is easy now. It is easy to just keep in mind. Na? You can easily keep this thing in mind and you can easily write it down. See, this is the first case. Now let me write second case. Suppose if my observer is going in this direction and my source is also going in this direction. Okay. So how can I write the formula? Tell me. F of naught will be nothing but, I will write down v naught divided by v vs multiplied by f of s. Watch it carefully. Observer is moving towards the source. Shall I write positive or negative first? Observer is moving towards the source. Shall I write positive or negative? Observer is moving towards the source. Write it down this and then you can easily write. Tell me. Observer is moving towards the source. So whenever if you are getting confused between observer and source and all those things, think like that. Observer is you and source is train. Got it? You are running towards the train. Shall I write positive or negative? If you are running towards the train, I will write positive. If you are running away from the train, I will write negative. If train is running towards you, you will write negative. If train is running away, you will write positive. But I hope now it is clear. So if you are running towards the train, what I'll write, I'm running towards the train, I will write positive. I'll write positive. But second case, my source is running away from train. Sorry, my source is running away from you. That means my train is running away from you. If my train is running away from you, which condition? Oh, train is running, that means case 2. Train is running with the case 2 and it is away, so train is running case 2 away. So I'll write positive or negative? I will write positive. Good, Sahana, good. So I'll write positive. Is it clear, guys? What will be my third case? We will be having totally 4 cases, guys. So I'm just launching the NPS. Please fill the NPS in middle also. Okay. And don't, oh my god, something had happened. No problem. Okay. My third case, guys. What will be my third case? My third case will be, I have took this case, right? Let me take this case. My observer is going in this direction and my source, why I'm writing on this A? My source is also going in this direction. Both are going in this left hand side direction. Tell me the formula. F naught will be nothing but I'll write V divided by V naught divided by Vs multiplied by F of S. Tell me if, see guys, this is observer, this is source. Source is train, observer is you. You, observer means you are running away from train. You are running away from train. Both negatives are good. You are running away from train. Negative. I'm running away from train. I'll write negative. Source is running, that is train is running towards the observer. I can tell. Train is running. This second case is for train. So second case is always for train. That's why I've written train. If train is running towards you, you will write negative. Simple thing, right? And we will be having fourth condition. Fourth condition. Fourth condition will be what? Both are moving apart from each other. So this is my source, this is my observer, this is my observer, okay, and this is my source. Both are moving apart from each other, guys. So what will be formula? Formula will F of naught will be nothing but V naught divided by Vs. Good, guys, good. Practice it once or more in your home with respect to you only. Okay, practice it so that you can feel comfortable. Got it? So if you have difficulty, you can ask me in the WhatsApp group. I'm going to reply you. Okay, so you can see my observer is moving away from source. Observer means me. If I am moving away from source, I should write negative. I'll write negative. Second thing, my source is moving away from observer. In both the cases, this is moving away. So my source is moving away. My source is moving. I'll write positive. I'll write positive. So this is a very easy technique through which you can easily solve most of the formulas and problems, and you can easily make yourself comfortable with this Dopplers effect. Most of the students leave this topic because formulas are big. They think that I cannot mug up or I cannot remember all these formulas. You don't have to remember all formulas. You just have to remember very small concept, and you have to remember this small concept. If you want to write it down in a smaller way, I can write it down in a much more smaller way for you. Okay, so if you want, I can write it out. So first case is with respect to you, and second case is with respect to train, right? You means you moving, train means train moving. Guys, NPS is not working today. I don't know, there's some problem. Okay, so in this, there are 2 cases coming into picture. That is towards and away. Over here also two pictures comes into picture, that is towards and away, right? In towards, when you are moving towards what? You are moving towards source, right? You are moving away from source. Train is moving towards you, and train is moving away from you. Simple thing. Positive, negative, positive. What all things will be increasing? I'll just write it down. Frequency increasing, right? Frequency increasing. Over here, frequency decreasing. Frequency. So I'll just write it down with respect to terms. right? So in the second case, when source is moving, when our source is moving, wavelength changes. This is an important point. Wavelength changes. Got it right? Is this clear to everyone, guys? Is this clear to everyone? Okay. Good. Increasing but near. Good, guys. Good to see that most of you guys are understanding it. Practice it today. Give 5 minutes time and spend 5 minutes topic in understanding and write it by yourself. Once or twice you will write it down. I'm damn sure once you will try to approach the problem, first thing that you need to find it, what is my source, what is my observer, and then implement it. Is it clear? And I hope you guys have understood the concept and like the class. Sorry, I cannot launch the poll. Thank you to everyone, guys. It went late actually. Uh, Next class might be took by Vishal sir or might be Rajendra sir. We will see how it's gonna happen. Okay. Okay. So can you tell me, guys, what all things have been left out last class? Because I have seen the last class video, sir was doing revision. So one student have told me that sir, need question have not been done. Any other thing that have been left out? Have you learned beats, tuning fork? Are these things are revision done? So next class, if I will be teaching you, I will be solving questions and I will be teaching you beats. And if need problems are there, please ping me that which problem you face difficulty, or I'm just gonna make you explain the concept. Okay. Okay, guys. Then thank you so much. Thank you so much for joining the class. We can wind up for today. We'll meet you next time. Stationary verse. Okay, Prakash.